The war demanded speed. Every aircraft, every mission, every second measured in lives saved or lost. Inside the vast hangars scattered across Allied air bases, mechanics worked through the night, fueling bombers, patching bullet holes, rushing fighters back into combat. The smell of aviation fuel hung permanent in the air, mixing with grease, sweat, and the metallic tang of riveted steel. These were not safe spaces. They were powder kegs with propellers. When fire came, it came fast. The roar of flames swallowing fabric wings, melting aluminum frames, exploding fuel tanks. It was the nightmare every airman knew but rarely spoke about. In those moments, training collapsed into instinct, and instinct often failed. Men ran. Equipment burned. Entire squadrons could vanish in minutes, not from enemy bombs, but from their own fuel and oxygen feeding an inferno no hose could touch. But on one base, during one desperate night in 1944, something different happened. An engineer, exhausted, soot-covered, watching helplessly as flames devoured a hangar filled with bombers, noticed something no one else had seen. A small metal panel, a ventilation damper left partially open, and in that tiny detail, he saw the answer. Not water, not foam. Air itself was the enemy. Cut the airflow, and the fire would suffocate. What followed was not heroism in the traditional sense. It was a quiet, terrifying gamble, closing vents while flames still raged, trusting physics over panic, betting lives on a theory no manual had ever taught. The fire died. The base survived. But the lesson it left behind would haunt everyone who witnessed it, a reminder that war's greatest dangers often hid in the smallest oversights. This is the story of that night, of the men who fought fire with silence, of the damper that saved a base, and of the fragile line between disaster and survival, drawn not by courage, but by one engineer's refusal to look away. Chapter 1. The Weight of Waiting. April 1944. The war was grinding forward, but for the men stationed at a remote Allied air base somewhere in the English countryside, progress felt measured in minutes stolen from chaos. Mechanics moved between aircraft like shadows, their hands blackened with oil, their eyes red from sleepless rotations. The hangar, a cathedral of corrugated steel and concrete, held 12 bombers in various states of repair, each one a promise to crews who would fly them into flak-filled skies at dawn. Before we continue, subscribe and turn on the bell. Here we tell real, untold stories of World War II, stories of fire, engineering, and the fragile moments of discovery that history almost forgot. The air inside was thick, not just from smoke or fumes, but from something heavier, anticipation laced with dread. Every man knew the statistics. 1 in 4 bombers didn't return. 1 in 10 bases lost aircraft not to combat, but to accidents on the ground. Fire was the silent predator, waiting in fuel lines, electrical panels, and the careless spark of a dropped wrench. Lieutenant Marcus Webb, a structural engineer reassigned from bridge building duty to airbase maintenance, walked the hangar floor with a clipboard he rarely used. His job was to ensure ventilation systems functioned, that fuel vapors dispersed properly, that the massive overhead dampers, designed to regulate airflow and temperature, stayed operational. It was unglamorous work. No one noticed when ventilation worked. Everyone noticed when it failed. That night, Webb noticed something else. The air wasn't moving right. The dampers, controlled by a manual crank system near the south wall, had been left partially open to cool the space during the day's work. Standard procedure. But as evening fell and temperatures dropped, no one had closed them. Cold air poured in from outside, mixing with the warm, fuel-heavy atmosphere inside, creating invisible currents that swirled through the hangar like unseen rivers. He made a note, reminded himself to check the dampers before lights out. Then the alarm bell rang. The fire started in Section C, near the fueling station. Later, investigators would argue about the cause: a faulty pump seal, a static discharge, an overheated generator. It didn't matter. Within seconds, flames leapt from the fuel cart to the wing of a B-17, racing along the fabric control surfaces, igniting hydraulic fluid, consuming oxygen faster than men could react. Sergeant Tom Callahan, a crew chief with 15 years in aviation, grabbed the nearest extinguisher and ran toward the blaze. The heat hit him like a physical wall. He squeezed the trigger. Foam sprayed. The flames barely noticed. Behind him, other men hauled hoses from wall-mounted reels, shouting coordinates, trying to establish a perimeter. But the fire was already moving, feeding on the very air they breathed. Webb stood frozen for 3 seconds, long enough to see the flames climb toward the ceiling, long enough to watch the ventilation dampers above the fire flutter and shake, sucking smoke upward while pulling fresh air in from below, long enough to understand what was happening. The dampers were feeding it. The open vents were turning the hangar into a chimney, drawing oxygen directly into the combustion zone, accelerating the burn with every breath the building took. He didn't run toward the fire, he ran toward the crank. Men shouted at him, confused, angry. There were bombers burning, lives at risk, equipment worth millions, and this engineer was turning a wheel on the wall like he was adjusting the thermostat. Webb ignored them. His hands moved fast, cranking the dampers closed, section by section, sealing the hangar's throat. The effect wasn't immediate. Flames still roared, smoke still billowed. But within 90 seconds, something shifted. The fire's voice changed from a howl to a wheeze. The orange glow dimmed slightly. Men on the hoses noticed it first. The flames weren't climbing anymore. They were shrinking, curling inward, starving. Callahan stopped spraying and stared. The fire was dying. Not from water, not from foam, from silence, from suffocation, from the absence of the one thing no one had thought to deny it. Webb's hands were still on the crank when the fire finally collapsed into smoldering wreckage. Around him, men breathed hard, coughing, disbelieving. The hangar reeked of burnt rubber and scorched metal, but the bombers in sections A and B stood untouched. 12 aircraft had been inside. 10 survived. No one spoke. Not yet. The weight of what had just happened, and what had almost happened, hung in the smoke-filled air, too heavy for words. Chapter 2. The silence. After the roar. The fire was out, but the hangar felt alive with ghosts. Smoke clung to the rafters, thick and gray, drifting in lazy spirals where the closed dampers had trapped it. The smell was overwhelming. Burnt paint, melted wiring, aviation fuel that had boiled but not exploded. Men moved slowly now, their adrenaline draining into exhaustion, their hands trembling as they coiled hoses and set down extinguishers they'd barely used. Sergeant Callahan stood near the wreckage of the B-17 in Section C, staring at the blackened skeleton of what had been a fully operational bomber 3 hours ago. The wings were gone, reduced to twisted aluminum ribs. The fuselage had collapsed inward, its belly ruptured where fuel tanks had ruptured and burned. But the fire had stopped here. It hadn't jumped to the next aircraft. It hadn't consumed the entire hangar. Somehow, impossibly, it had simply quit. He turned and looked across the hangar floor to where Lieutenant Webb still stood by the damper controls, his uniform streaked with soot, his face unreadable. Other men were looking too now, mechanics and crew chiefs and firefighters, all of them trying to piece together what had just happened. Captain Raymond Howell, the base fire marshal, arrived 12 minutes after the alarm had sounded. Late because he'd been coordinating with the airfield tower to reroute incoming aircraft away from the smoke. He was a career firefighter, trained in Boston before the war, a man who'd seen warehouse fires, ship fires, fuel depot fires. He knew how aircraft burned. He knew you fought them with foam, with sand, with distance. You didn't fight them by closing vents. He walked the perimeter of the burn zone, his boots crunching on debris, his flashlight sweeping over scorched concrete and melted equipment. When he reached Webb, he stopped. "You closed the dampers." It wasn't a question. Webb nodded. "During an active fire." "Yes, sir." Howell's jaw tightened. "That's not protocol. You could have trapped men inside, could have concentrated the smoke, could have made it worse." Webb met his eyes. It made it better. The two men stood in silence, the weight of that statement hanging between them. Around them, other personnel had begun the grim work of damage assessment, cataloging lost equipment, checking structural integrity, searching for injuries. Miraculously, there were none. Burns, yes. Smoke inhalation, certainly, but no one had been trapped. No one had died. Howell crouched near the fuel cart where the fire had started, examining the scorch patterns on the concrete. The burn marks radiated outward in a specific pattern, darker and deeper near the ventilation shaft that fed into the damper system. He'd seen patterns like this before, in industrial fires where airflow had accelerated combustion, but he'd never seen one stop mid-burn. "Walk me through it," Howell said, standing. "Step by step," Webb explained. The open dampers, the cold air pouring in from outside, the way the fire had climbed toward the ceiling, following the draft like a living thing, how closing the vents had cut off that flow, starving the flames of the oxygen current they'd been riding. "It's basic combustion theory," Webb said quietly. "Fire needs 3 things: fuel, heat, and oxygen. We couldn't remove the fuel fast enough. We couldn't cool it fast enough. But we could control the air. Howell listened without interrupting. When Webb finished, the fire marshal pulled out a pack of cigarettes, then thought better of it, and put them away. You know what you did was insane. Yes, sir. You know it worked anyway. Yes, sir. Howell looked back at the wreckage, then at the 10 intact bombers still standing in the undamaged sections. He did the math silently. Aircraft saved, missions preserved, lives that would fly tomorrow because of what hadn't burned tonight. Then he looked at Webb again. You're writing the report. Every detail, every measurement, every damper setting. I want it on my desk by morning. Webb nodded. And Webb, Howell's voice softened slightly. Don't ever do something that stupid again without telling me first. The lieutenant almost smiled. Understood, sir. Chapter 3. The Theory. No one taught. The report took Webb 4 hours to write. He sat in the base operations office, alone, except for the night shift radio operator dozing at his console, and reconstructed the fire minute by minute. He sketched the hangar layout, marked airflow patterns, calculated ventilation rates and oxygen concentration levels. He described the moment he'd seen the flames respond to the draft, the way they'd leaned toward the open dampers like flowers turning toward light. It should have been obvious, he wrote, but obvious things rarely were in the chaos of an emergency. He included a section on combustion dynamics, citing principles he'd learned in engineering school, principles designed for blast furnaces and industrial boilers, not aircraft hangars. He noted that military fire protocols focused almost entirely on suppression through water, foam, or chemical agents. Nowhere in the standard manuals was there guidance on controlling ventilation during an active blaze. That omission, he wrote carefully, had nearly cost them everything. Now tell us in the comments where you're watching from, and how far these forgotten wartime stories have reached. Your voice helps keep memory alive. When dawn broke, Webb delivered the report to Captain Howell's office. The fire marshal read it twice, making notes in the margins, occasionally shaking his head. When he finished, he looked up at Webb, who stood at attention despite not having slept. This is going to upset people, Howell said. Yes, sir. You're saying our entire fire response doctrine is incomplete. I'm saying it doesn't account for airflow as a variable, sir. Howell leaned back in his chair. You know what happens when you tell the Air Corps they've been doing something wrong? Webb said nothing. They court-martial you or they promote you. Sometimes both. Howell tapped the report. I'm sending this up the chain. Prepare to explain yourself to people with more stars than sense. Over the following week, Webb did exactly that. He briefed the base commander, then a visiting colonel from Air Corps Engineering, then a team of civilian fire scientists contracted by the War Department. Each time he walked them through the same sequence, the open dampers, the accelerated burn, the suffocation effect. Some were skeptical. One colonel insisted that closing vents during a fire was suicide, that Webb had simply gotten lucky, that foam and water had done the real work. But the burn patterns didn't lie. Neither did the math, and neither did the 10 bombers still standing in sections A and B ready to fly. The civilian scientists were more receptive. They conducted tests using scale models and controlled burns, replicating the airflow dynamics Webb had described. The results were consistent. Starving a fire of oxygen, when done correctly, with proper ventilation control, could suppress combustion faster than traditional methods. It wasn't a replacement for firefighting, they concluded. It was a tool, a variable, something that had been overlooked because hangars, unlike buildings, were designed to breathe. That design feature, meant to protect personnel from fuel vapors, had inadvertently created perfect conditions for accelerated combustion. The War Department issued a technical bulletin 3 months later, Ventilation Control in Aircraft Hangar Fire Suppression. It was dry, bureaucratic, filled with diagrams and calculations. But buried in its pages was a revolution, a new protocol that would be adopted across Allied air bases, then studied by post-war fire departments, then incorporated into building codes that would shape industrial safety for decades. Webb never saw most of that impact. By the time the bulletin was distributed, he'd been reassigned to another base, then another project, swept along by the war's momentum. But he kept a copy of his original report, folded in his footlocker, a reminder of the night when everything he'd been taught about fire had proven incomplete. And he kept thinking about the damper, that tiny metal panel, that simple crank, how something so small could make the difference between disaster and survival, between losing everything and saving just enough to keep fighting. Chapter 4. The Cost of Knowledge. The burned B-17 in Section C was dismantled over 3 days, its remains hauled away in trucks, its serial number recorded in logs that would eventually become footnotes in maintenance reports. No one would fly it again. No crew would trust their lives to its reconstructed frame. It became a casualty of war without ever leaving the ground, a sacrifice to the lesson it had taught. The mechanics who'd worked on it felt the loss personally. Staff Sergeant Eugene Parks had spent 8 days repairing that bomber's port engine, replacing cylinder heads, calibrating timing sequences, test running it, until the roar was perfect. Now that engine was scrap metal, its hours of labor erased in minutes of flame. He stood in the empty space where the aircraft had been, staring at the scorched concrete, a coffee mug cooling in his hands. Other men passed by, returning to work on the surviving bombers, their routines resuming as if nothing had changed. But Parks couldn't shake the feeling that something fundamental had shifted, that the hangar itself had become a different place. Lieutenant Webb found him there during the afternoon shift change. Parks didn't turn around, but he spoke anyway. "You saved the others." Webb said nothing for a moment. Then, "I got lucky. Luck doesn't close dampers." Parks finally looked at him. "You saw something no one else did. You acted when everyone else was just reacting." "I hesitated," Webb said quietly. 3 seconds, maybe 4. Long enough to doubt myself. Long enough that more could have burned. Parks nodded slowly. But they didn't. The two men stood in the burned space, surrounded by the sounds of the working hangar, pneumatic tools, rolling carts, distant radio chatter. Around them, the war continued. Missions launched, aircraft returned, the rhythm of base life resumed. But for those who'd been there that night, who'd seen the fire climb and then collapse, who'd watched physics overrule panic, the memory remained sharp. Captain Howell began conducting training sessions, walking personnel through the new ventilation protocols. He used the burned section as a classroom, pointing to scorch marks and airflow patterns, explaining how fire behavior changed with environment. The sessions were mandatory. Attendance was sullen at first. Men resented being pulled from critical work for what felt like academic lectures. But Howell was a good teacher. He didn't theorize. He showed them the damper controls, made them practice the shutdown sequence, had them time how fast they could seal a section. He brought in thermometers and smoke generators, demonstrating how quickly heat rose, how drafts formed, how ventilation could feed or starve a blaze. "Fire isn't the enemy," he told them during one session. "Fire is a chemical reaction. It's predictable. It follows rules. The enemy is ignorance, not knowing those rules, not seeing the variables, not understanding that sometimes the best way to fight is to stop feeding what you're fighting." The men listened. Some took notes. A few asked questions. Slowly, grudgingly, the lesson took root. Webb attended these sessions when his duties allowed, always standing at the back, never speaking unless asked a direct question. He watched the personnel learn, watched them practice, watched the knowledge spread. It felt strange being the source of something that might save lives. All his training had been about structures, bridges, roads, fortifications. He'd never imagined his contribution to the war would involve fire. One evening, as the hangar emptied for shift change, a young mechanic approached him, barely 20, fresh from stateside training, his uniform still crisp. His name tag read, Harrison. "Sir, I wanted to ask..." Harrison hesitated. "During the fire, when you decided to close the dampers, how did you know it would work?" Webb considered the question carefully. "I didn't know. I suspected. There's a difference. But you did it anyway." The alternative was worse. Harrison frowned, processing this. "They teach us to follow procedures, to stick to the manual. You went against that." "No," Webb corrected gently. "I recognized that the manual was incomplete. There's a difference there, too." The young mechanic nodded slowly, then walked away, leaving Webb alone with his thoughts. That night, lying in his bunk, Webb replayed the fire again in his mind, a habit he couldn't break. He saw the flames, heard the shouts, felt his hands on the crank. But now, weeks later, he also saw what had come after: the training, the protocols, the knowledge spreading to other bases, other personnel, other engineers who might face similar emergencies. One fire, one decision, one small damper. How many lives would it save? Impossible to calculate. The war was too vast, too chaotic. Success was often invisible. Missions that didn't fail, bases that didn't burn, men who came home because disaster had been prevented rather than survived. Webb closed his eyes, letting exhaustion finally claim him. Tomorrow there would be more work, ventilation systems to inspect, maintenance schedules to coordinate. The endless grinding routine of keeping an airbase operational. The war would continue. The fires would keep threatening. And somewhere, in hangars he'd never see, engineers would face their own moments of choice. He hoped they'd remember the lesson. He hoped they'd see the variables. He hoped, when the time came, they wouldn't hesitate as long as he had. 3 seconds. Maybe 4. In war, that was an eternity. Chapter 5. The Ripple Effect. News traveled slowly across military installations during wartime, filtered through official channels, sanitized by censors, reduced to bullet points in technical memos. But among engineers and fire personnel, word spread differently, in mess halls, in maintenance sheds, in the informal networks that connected people who shared specialized knowledge. By June 1944, 3 other air bases had reported using ventilation control to suppress hangar fires, 2 in England, 1 in North Africa. The incidents varied, different ignition sources, different aircraft types, different facility designs, but the principle remained constant. Cut the airflow, starve the reaction, control the variables. Captain Howell received copies of these reports, forwarded by Air Corps Command with terse notes requesting his assessment. He read them carefully, comparing burn patterns and response times, looking for commonalities and deviations. Then he walked them over to Webb's workstation and dropped them on his desk. "You started something," Howell said. Webb looked up from the ventilation diagram he'd been annotating. He scanned the reports quickly, his expression unreadable. "Any failures?" he asked. "1. North Africa base. They closed the dampers too early, before establishing foam coverage. Trapped smoke and heat, forced personnel to evacuate. Fire spread to adjacent sections before they could regain control." Webb nodded slowly. "So it's not a universal solution. Nothing ever is?" Howell pulled up a chair. "But it's a tool. Used correctly, in the right circumstances, it works. Used incorrectly." He gestured at the North Africa report. "It makes things worse. Then the training matters more than the technique." "Exactly." Howell leaned back. "Which is why you're coming with me next week. Fighter base in Scotland. They've had 3 fuel fires in 2 months. Command wants someone who understands both the engineering and the practical application." Webb blinked. "I'm maintenance engineering, sir. Not instruction. You're the guy who saw what no one else saw. That makes you qualified." Howell stood. "Pack for 5 days. We leave Tuesday." The Scotland trip was the first of many. Over the following months, Webb found himself traveling between bases, conducting assessments, reviewing fire response protocols, training personnel on ventilation dynamics. It wasn't the work he'd enlisted to do. It wasn't combat engineering or infrastructure development, but it was necessary, and it was his. The bases blurred together after a while. Different accents, different weather, same hangars, same dangers, same tired men trying to keep aircraft flying and fires from burning. Webb gave the same presentations, demonstrated the same principles, answered the same questions, but each time, he adjusted his approach slightly, learning from previous sessions, finding better ways to explain complex concepts to people who worked with their hands more than their minds. He met other engineers, other fire marshals, other specialists who'd discovered their own lessons the hard way. A Navy lieutenant who'd developed foam application techniques for carrier deck fires. An Army captain who'd redesigned fuel storage protocols after a depot explosion. A civilian consultant who'd spent 30 years studying industrial combustion and now found himself teaching military personnel half his age. They formed an informal community. These specialists, bound by shared experience and the weight of knowledge gained through near disaster. They traded notes, compared methods, challenged each other's assumptions. Webb learned that his damper technique was one piece of a larger puzzle, that fire suppression required multiple approaches, coordinated responses, constant adaptation. He also learned that innovation in wartime was complicated. For every commander who embraced new methods, there were 2 who resisted change, who clung to established protocols, who viewed any deviation as dangerous individualism. Webb sat through meetings where colonels dismissed ventilation control as experimental, where fire marshals argued that traditional suppression had worked for decades and needed no revision. The resistance frustrated him at first, but Howell, who'd navigated military bureaucracy far longer, offered perspective. "They're not wrong to be cautious," he said during one trip back to their home base. "Every new technique carries risk. Every change creates uncertainty. They're responsible for hundreds of lives, billions of dollars in equipment. They don't have the luxury of experimentation. But we proved it works. We proved it worked once, in specific conditions. with specific variables. Howell glanced at him. That's not the same as proving it works everywhere, always, for everyone. Real innovation isn't about one good idea. It's about refining that idea through repeated testing, documentation, institutional acceptance. It's boring. It's slow. But it's how knowledge actually spreads. Webb absorbed this, recognizing the truth in it. His moment at the damper controls had been dramatic. 3 seconds of decision under pressure. But the real work came after, in the unglamorous hours of report writing, training sessions, protocol revisions, and bureaucratic navigation. That work continued through the summer of 1944, even as the war itself intensified. D-Day came and went. Allied forces pushed deeper into Europe. The pace of operations increased, and with it, the pressure on air bases to maintain constant readiness. Fires became more frequent, rushed maintenance, exhausted personnel, equipment pushed past its limits. But the losses decreased, not everywhere, not immediately, but gradually, measurably. Bases that had adopted ventilation awareness reported fewer catastrophic burns, faster suppression times, more aircraft saved. The data accumulated slowly, documented in maintenance logs and incident reports, building the case that Howell had said was necessary. Webb saw none of the strategic impact. He only saw the individual faces, mechanics who nodded when he explained airflow patterns, fire crews who practiced damper shutdown sequences, engineers who asked follow-up questions and then went back to their bases to implement changes. Small moments, small victories. The slow, incremental spread of knowledge through a vast military machine. It wasn't glory, it wasn't heroism, but it was something, and in a war that consumed men and machines with industrial efficiency, something was more than nothing. Chapter 6. The Weight of Prevention. By autumn 1944, Lieutenant Webb had visited 17 air bases across 3 continents. His footlocker contained a growing collection of ventilation schematics, incident reports, and handwritten notes from personnel he'd trained. His uniform jacket bore no medals, no combat insignia, no visible evidence of his contribution. But in maintenance offices and fire stations across the Allied air network, his name had become synonymous with a specific kind of expertise. He was the damper guy, the ventilation specialist, the engineer who'd figured out how to suffocate fires without water. The label felt reductive, but Webb didn't resist it. In military culture, reputation required simplification. Complex ideas needed to be compressed into memorable phrases, technical knowledge reduced to actionable principles. If "close the dampers" was what people remembered, then that was enough. What bothered him more was what wasn't being measured. The fires that didn't happen, the disasters that never occurred because someone had tightened a seal or adjusted a vent or noticed an airflow irregularity before ignition. Prevention left no dramatic evidence, no burned wreckage to photograph, no rescue stories to tell. Captain Howell understood this better than most. During one of their trips, this time to a bomber base in Italy, he and Webb stood outside a freshly inspected hangar, watching the sun set over distant mountains, the air cooling rapidly as evening approached. "You know what success looks like in our work," Howell said, lighting the cigarette he'd denied himself months ago. "Nothing. Absolutely nothing. No fires, no alarms, no emergency responses. Just another day where everything worked as designed." Webb nodded. "Hard to get recognition for that." "Impossible, actually." Howell exhaled smoke. "But that's the job. We're not heroes. We're janitors. We clean up the invisible problems before they become visible disasters. You think that matters? Long term? If this story has moved you, leave a like. It helps others discover how humanity can survive even inside the walls of captivity." Howell considered this. "I think it matters to the mechanics who don't burn, the pilots who fly aircraft that weren't destroyed on the ground, the families who get their sons back because a hangar didn't explode." He flicked ash. "But no, they'll never know your name. Neither will history. You good with that?" Webb thought about the question honestly. He'd entered the war imagining different contributions, bridges built under fire, fortifications designed under pressure, tangible structures that would remain after the fighting ended. Instead, he'd spent a year teaching people about airflow. It felt small. It felt insufficient. But then he thought about the bombers in Section B, the ones that hadn't burned, the crews who'd flown them the next day, and the day after, and the week after. Missions completed, bombs delivered, perhaps lives saved through whatever targets those missions had eliminated. How did you measure that? How did you calculate the value of preservation versus creation? I'm good with it, he said finally. Howell nodded. Good, because there's more work coming. The work intensified as winter approached. The War Department, finally convinced by accumulated data, issued formal guidance integrating ventilation control into standard fire response protocols. The technical bulletin Webb and Howell had helped author became required reading for all base fire personnel. Training modules were developed. Equipment specifications were updated. What had started as one engineer's improvisation became institutional doctrine, but doctrine required enforcement, and enforcement required people. Webb found himself training trainers, senior fire marshals and engineering officers who would return to their regions and propagate the knowledge further. He taught them not just the techniques, but the reasoning behind them, the physics that made ventilation control effective, the conditions that made it appropriate. Some students were better than others. Some asked probing questions, challenged assumptions, pushed back against aspects they didn't understand. Others simply copied notes, memorized procedures, treated the training as one more bureaucratic requirement to complete before returning to their real responsibilities. Webb worried about the second group. Ventilation control wasn't a checkbox. It required judgment, understanding when to close dampers versus when to keep them open, when to prioritize oxygen starvation versus heat dissipation, when traditional suppression methods were more appropriate. Get it wrong, and you could make things worse. He said as much during one training session, addressing a room full of fire marshals from various Pacific theater bases. This isn't a universal solution. It's a tool, and like any tool, it can cause harm if misused. If you take nothing else from this training, take this. Think before you act. Assess the situation. Understand the variables. Don't just follow procedure. Understand why the procedure exists. One marshal, a grizzled veteran with burn scars on his forearms, raised his hand. With respect, Lieutenant, in an emergency there's no time to think. You react, or people die. Webb met his eyes. Then you practice until thinking becomes reaction. You drill until assessment becomes instinct. Because the wrong reaction, executed quickly, kills just as surely as no reaction at all. The room went quiet. Webb realized he'd spoken more forcefully than intended, that his frustration with procedural thinking had leaked into his tone. But he didn't soften the message. These men would return to their bases, train their own personnel, respond to their own emergencies. They needed to understand not just what to do, but why, and when not to. After the session, the scarred marshal approached him privately. You're right, he said quietly. I've seen men die because someone did the wrong thing fast. Better to do the right thing slow if you can. He paused. But you can't always. Sometimes war doesn't give you time to think. Webb nodded. I know. That's why the training matters. Then keep training us. Keep pushing. Because what you're teaching, it'll save lives. Maybe not today. Maybe not in ways we can measure. But it'll matter. The marshal walked away, leaving Webb alone with his thoughts. That night, writing his daily report in a tent lit by a single lantern, Webb reflected on the year that had passed since the Hangar fire. He'd traveled thousands of miles, trained hundreds of personnel, contributed to doctrine that would outlast the war, but he still couldn't shake the feeling that his real contribution had happened in those 3 seconds, 4 seconds, when he'd chosen to trust physics over protocol. Everything else was just explaining that choice to people who hadn't been there.